Suppose that S is a finite set of positive integers. If the greatest integer in S is removed from S, then the average value of the integer remaining is 32. Greatest is removed, the average is 32. If the least integer in S is also removed, then the average value of the integer remaining is 35. The greatest integer and the least integer removed, then average is 35. If the greatest integer is then returned to the set, the average value of the integer rises to 40. The greatest integer in the original set as 72 greater than the least integer. What is the average value of all these integers? I'm going to say, first of all, the sum of all numbers in S is T. We have n numbers, let's say, n numbers. We have greatest integer, let's say it is x, and then least integer is y. And then we are going to write some equations for that. Let's write the first equation. We will remove the greatest integer, which means t minus x divided by n minus 1 is equal to 32 is the average. That's our first equation. The second equation, we are going to remove also the least integer. Therefore, we are dividing by n minus 2. Then the average value is 34. Later, we are going to return greatest integer inside. So just we have t minus the lowest divided by n minus 1. This time the average is 40. And we have number 4, which is the greatest integer 72 is more than the least integer. We are looking for what is the average, t divided by n. That's what we are looking for. We have to find t, we have to find n. First of all, let's make the cross product and write each equation. Number 1, which is t minus x is equal to 32 times n minus 1. The second equation, t minus x minus y is equal to 35 times n minus 2. The third equation, t minus y is equal to 40 times n minus 1. And I'm going to focus on the first and the last equation, the first and the last. If we take those two, let's subtract side by side. Let's rewrite them. T minus x is equal to 32n minus 32. T minus y is equal to 40n minus 40. Here, if I subtract, let's subtract the first equation, minus, plus, minus, plus. And add side by side, we can eliminate the t's. T's eliminated. X minus y is equal to 40n minus 32n will be 8n minus 8. And from the last equation, x minus y is equal to 72. We can just substitute the 72 is equal to 8n minus 8. If we add 8 both sides, 8n is equal to, it's going to be 80, n is equal to 10. We just find how many numbers are in the set, which is 10. Great. Let's use that one. Then what we have from the equation, t minus x is equal to 32 times 10 minus 1, which is 9. T minus x minus y is equal to 35 times 10 minus 2, which is 8. The third equation, t minus y is equal to 40 times 9. Again, let's take the first and the second equation, first and the third. Let's take first and the third, add side by side. What will happen if I take this one and this one, add side by side? If I add side by side, I'm going to have 2t minus x minus y is equal to 32 plus 40 is 72. 72 times 9. All right. The second equation here, t minus x minus y. We have t minus x plus y is equal to 35 times 8. And I am looking for t. If I find t, I can find the average. So what I will do is let's subtract the second equation from the first. 2t minus t is just t, and this will cancels out. What I have here, 72 times 9 minus 35 times 8. Great. And then I found my t, I found my n. Now if I calculate t, I can get the average. 72 times 9 is equal to 2 times 9 is 18. 7 times 9 is 63, plus 1 is 64. 35 times 8 is 8 times 5 is 40. 8 times 3 is 24, plus 4 is 28. 648 minus 280, which is going to be 8. 14 minus this is going to be 6. 5 minus 2 is 3. 368 is going to be the sum of the numbers. Then t divided by n is equal to 368 divided by 10. 36.8 is going to be the average of all numbers. 36.8, answer choice D.